So yesterday when we learned 5.1, we learned in order to write an equation in slope-intercept form, we have to know M and we have to know B. So we plugged those in, wrote our equation in slope-intercept form. So today, they still want us to write an equation in slope-intercept form, but they've left out one or more of those things. So the first example that we're going to do today says, write an equation for the line, just means slope-intercept form, that passes through the point 6, -3, and has a slope of -2. So what are the two things that we said we have to have in order to write an equation in slope-intercept? Jordan? Slope and y-intercept. So I need an M and I need a B. In this problem right here, I know that M is -2. But do I know B? Do I know my y-intercept? No, I don't. You cannot say, oh yeah, we do. That's y. Y is -3. No, that is not the y-intercept. That's just a point on the graph. In order for that to be the y-intercept, the x would have to be 0. Remember back in 4.1 to 4.5 when we learned how to find x and y-intercepts? If I wanted to find the y-intercept, I plugged in a 0 for x. That's what that point would have to be if it was the y-intercept, 0, comma, whatever the number is. Since it's not, we know that's not y-intercept, we just know it's a point. But I know that a point always stands for what, comma, what? I hear it. What is it? X, comma, y. Perfect. So I know that 6 is x and -3 is y. We already said, okay, we don't know what B is, but I know M, I know X, and I know Y. Now, there's been a lot of questions since we started slope-intercept form, which remember is Y equals MX plus B, of people that say, okay, why is the y-intercept B? Why isn't it not X? Or Y, I'm sorry, why is it not Y? Well, because X and Y are always letters that stand for ordered pairs. So when I get an equation in slope-intercept form, I want to have it so that X and Y are blank so I can plug in any point that I know and say, yes, it's going to be on the line, or no, it's not. Well, they tell us, okay, that this ordered pair is on the line. So guess what? I'm going to use that X and Y to finally get some use out of the X and Y in slope-intercept form. So I know Y, I know M, because we know it's -2, and I know X. But what do I not know still? B. So I'm just going to plug it into my equation and solve for B. It becomes a problem that we would have done probably back in chapter 2. So we know that Y is -3 equals M, which is -2, times X, which is 6, plus B. So all I want to do is solve for B. So what would I do first, Jared, to solve for B?
Get rid of the -3?
I can't get rid of the -3 because I want to get B by itself. So what should I do here?
Get rid of the -2. From 6.
By doing what?
The opposite.
Not the opposite. Kim, what would I do there? Just multiply. All I want to do is multiply 2 and 6. Or I'm sorry, -2 and 6. So I get -3 equals -12 plus B. Now what do I want to get rid of? Michael? The -12, and how would I do that? Add 12. Because 12 is negative, I want to add it to the other side to get B by itself. What's -3 plus 12? 9. So now I know 9 equals B. I'm just boxing it in so you can see it. However, that is not my final answer. What they told us to do was write an equation in slope-intercept form. So I have to know M, and I have to know B, right, Christian? Okay, so plug it back in and tell me what my final answer is going to be.
So you plug it back in?
Mm-hmm.
So you do y equals -2x plus
Perfect. You say, wait a second, I thought we knew X and Y, so why don't we plug those in? You never plug in an ordered pair whenever we're writing an equation in slope-intercept form. We always leave X and Y blank so that I can plug in ordered pairs and say, yes, it is a solution, or no, it's not, okay? So this is my final answer. if you box in m equals -2, b equals 9, your answer will be wrong. It has to be written in slope-intercept form. Okay, so let's do the same thing on the next problem. Write an equation for the line that passes through the point -3, 0 and has a slope of 1/3. So Dion, what do I know? I know the slope, and what's my slope? 1/3, so I can say m equals 1/3. What else do I know, Michael? Okay, or Dion, tell me what else do I know? X and y. Because I have -3 is x, 0 is y. What is the only thing I'm missing? B. So let's plug it into our equation and solve. I know my formula is y equals mx plus b, so I say y, which is 0, equals m, which is 1/3, times x, which is -3, plus b. What is 1/3 times -3? -1. Very good, -1. If that did not come to you quickly, make sure you plug it in your calculators. Basically what happens there is the 3's cancel out, and I'm left with -1. Okay, so anyway, so now I have 0 equals -1 plus b. What would I do to get b by itself? Add 1, and b equals 1. Now can I write my final answer? And what is that going to be, Kim?
Y equals 1/3.
Perfect. Y equals 1/3 x plus 1. So then example 2 goes one step farther. It never changes. The two things I have to know in order to write an equation in slope-intercept form are m and b. I'm going to keep asking that because you have to know that. All right. So let's read this problem. Write an equation for the line, slope-intercept form, that passes through the point 1, 6 and 3, -4. So, do I have m? No. Do I have b? No. So how am I going to write an equation for a line when I don't know either thing I need to in order to write it? Well, we're going to use a particular formula that we have learned back at the beginning of chapter 4. Who can raise your hand and tell me what that formula is? Josh Ferris?
M equals y sub 2 minus sub 1, divided by the x sub 2 minus x sub 1.
Perfect. M equals y2 minus y1 over x2 minus x1. If you remember, you had to write that on your last test. We can use this formula because I've got two ordered pairs. I've got an x and a y and an x and a y. So let's plug that in and find m. I always have to do that first. So we're going to say y2, which is -4, so m equals -4, minus y1, which is 6, over 3 minus 1. -4 minus 6, same signs, add and keep, -10. 3 minus 1 is 2. What's -10 divided by 2? So our slope is -5. There's part of our answer. I need an m and a b, so what am I still missing? B. But remember what we did last example? When I knew my m and a point, I could plug it into y equals mx plus b and solve for b. Do I know my m? Yeah. Do I have a point? Yeah. Actually, I have 2. And I can choose either one I want. You can plug in 1, 6, or you can plug in 3, -4. Either one will give you the exact same b. So I'm going to use the first numbers here, 1, 6. And we're going to say y, so that's 6, equals m, which is -5, times x, which is 1, plus b. -5 times 1 is -5 plus b. So then what am I going to do to get b by itself? Add 5. And what does b equal? b equals 11. So now do I have the two things I need in order to write a slope-intercept form equation? Yep. Again, remember we never plug in our x and y, so we're going to say y equals m, which is negative 5x plus 11. Perfect. All right, so I'm going to go ahead and erase this work so I have room to do the second part of this example, which they want us to do the exact same thing. Write an equation for the line that passes through the points negative 3, 1, and 5, 5. So what do I need to start out by doing? Kim? What's that? Okay, which formula am I going to use?
M equals y sub 2 minus y sub 9 over x sub 2 minus.
Perfect. y2 minus y1 over x2 minus x1. All right, JT, plug in the numbers for me.
Five
5 minus 1
minus one.
over.
5 minus negative 3.
Perfect. Minus negative 3. What do you see that has to be taken care of before we ever move forward, Dion? Double negative. What does that double negative change to? Positive. 5 minus 1 is 4. 5 plus 3 is 8. Can I reduce 4 eighths? Yes, and you have to. Never leave your slope as an unreduced fraction. 4 eighths simplifies down to 1/2. So 1/2 equals m. So now, I know m. What else am I still missing? B. How am I going to find B? Josh?
Y equals 1/2 times 1 plus b.
Okay, so we're going to plug in our y and our x into our slope-intercept form and solve for b. Now, do y'all want to use the negative 3, 1 ordered pair or 5, 5? All right, let's do 5, 5. So we're going to say 5 equals m, which is 1/2, x, which is 5, plus b. This is where you're probably going to want to use your calculator to help you because we're going to have to get common denominators and things like that in our heads if we don't use a calculator. So what's 5 times 1/2? 2.5 plus b. Now, if you were to write it as a fraction, we would write 5 over 2 or 2.5, either way. So what would I do now to get b by itself? Subtract 2.5. Now, when you do it as a decimal, it actually makes it a lot easier. b equals 2.5. However, it's fine if you write your y-intercept as a fraction. I'm sorry, as a decimal. But am I ever allowed to write my slope as a decimal? No. So just be very careful that if you write your y-intercept as a decimal, that you do not do the same thing for the slope because the slope is rise over run. So it has to be in fraction form. So I can write my final answer as y equals 1/2 x plus, I'm going to write this as a fraction just because I like to stay consistent. If I start with a fraction, I want to end with a fraction. 2.5. That would be our answer for the second example. If you wrote y equals 1/2 x plus 5 over 2, that's also right. Or y equals 1/2 x plus 2.5, that is also right. Okay? So what we want to do now is they want us to identify, are the lines parallel or perpendicular, which we're going to get to in the next example. The definition for parallel lines are lines that never intersect. So you're saying, Miss Reber, do I have to graph both of these lines to find out if they're never going to touch? No. There's actually a very simple shortcut about parallel lines that I can always use. And you're going to want to write this down. Parallel lines have the same, anybody know? Slope. Parallel lines have the same slope. What letter represents slope? M. So I can take my equation, and if it's in y equals mx plus b, I can look at the m and say, Do both of them have the same slope? If it's yes, then they're parallel lines. If it's no, then they're not. So are these equations in slope-intercept form? Yeah, y equals negative 3x plus 2, y equals 3x plus 5. So let's identify their slope. What is the slope, or m, in the first equation? Negative 3. And what is the slope in the second equation? 3. Are these parallel lines? Look at what their slopes are. The first one's negative 3 and the second one's positive 3. No, they have to be exactly the same to be parallel lines. So my answer is no, because they do not have the same slope. But look at the next example. Y equals 5x plus 9 and 5y equals 25x plus 25. First of all, let's ask ourselves this question. Are both of these equations in slope-intercept form? No, not the second equation, because what's still in front of the second equation that needs to be moved? The 5. How do I move the 5? Divide. So my new equation in slope-intercept form is y equals 5x plus 5. So now let's identify the slopes. The slope in the first equation is m equals 5. And the slope in the second equation is m equals 5. So are these lines parallel? Yes, they are. If you were to have looked at this equation right off the bat and said, oh, 5 and 25, no, they're not parallel. Well, it has to be in slope-intercept form first. Has to be in slope-intercept form first. So the next example, they want us to tell, are the lines perpendicular? We said parallel lines never intersect because they have the same slope. So if you think about it, they're going to be going the exact same direction with the same slope the whole time, so they'll never intersect. But we said the definition of perpendicular lines is they intersect at a 90-degree angle, or a right angle. Again, instead of me graphing these lines and saying, oh yeah, they intersect at a 90-degree angle, because then I'd have to get out a compass and all kinds of stuff, make sure the angle's 90 degrees, that's just going to get too much. So, just like parallel lines have the same slope, there's a little trick to identifying perpendicular lines. Perpendicular lines have an opposite reciprocal slope. And you say, well, that sounds really confusing. Well, write this down first, and then I'll show you what I mean. Opposite reciprocal slope. The word opposite, what it means is if I have a positive, the opposite is negative. Vice versa, if I have a negative, the opposite's positive. So there's that word, it's pretty simple. Second word, reciprocal. We learned about reciprocals back at the beginning of the year. What is a reciprocal, Michael?
When you switch the fraction.
When we flip the fraction. So for instance, if I were to have 1/2, what is the reciprocal of 1/2? 2 over 1 or 2. Now, opposite would mean if 1/2 was positive, the 2 would have to be negative. That is an opposite reciprocal slope, so I know these lines would be parallel. I'm sorry, perpendicular. So let's check these out. My slope in the first, well, first of all, let's ask ourselves, are the equations in slope-intercept form? Yeah. So let's identify the slope in the first equation, which is 5. What is the slope in the second equation? 1/5. So let's ask ourselves, are they opposites? No. In order for them to be opposites, one would have to be positive and one would have to be negative. They're both positive. So right off the bat, I know they're not going to be perpendicular. I can stop right there. But what would be the second question? I would say, are they reciprocal? Yeah, actually it is the reciprocal, but because it's not opposite reciprocal, it has to be both in order to be a perpendicular line. So my answer is no. So let's look at the next equation. Are these equations in slope-intercept form? Yes. So let's identify slope. M equals 2/3 and M equals negative 2/3. Are they opposites? Yeah. One's positive, one's negative. Are they reciprocals? No. They're the same fraction. In order for it to be reciprocals, the first one would have to be 2/3 and the second would have to be 3 over 2, or negative 3 over 2. So our answer again is no. They are not perpendicular lines. So parallel lines have the same what? Slope. And perpendicular lines have what? Opposite reciprocal slopes. Okay? Here is the homework for tonight. Page 5.2, I'm sorry, homework 5.2 and 5.3, page 282, 12 through 15 all, and 288, 24 through 29 all. You do not have to graph any of these problems. So even if your book says to graph it, you do not. I want you to use the way that we did it in our examples to find out the slope-intercept form.